We will talk today about virtualization on Kubernetes. It's a topic that it's out there since a lot of time. Probably you have heard that it can be done. Today we will see how we can done. And special gift will be a repository with a Terraform provider, KubeVirt, that you can run basically on your home computer, the same thing that you are going to see. So let's start here. Let's see if I can move the presentation, or I will have to do something like, because again, I'm not having the mirroring working, and the space is either working. So we will do a presentation that is just manual. It was the same the last year. This is the beginning, breaking free from a legacy virtualization. This should work now. Let's see. Yeah. Agenda. So we will start with a brief introduction. Virtualization systems are out there since the 60s. You maybe will say, no, impossible. I know that VMware started in the 90s. We will see why it's not that way. Then the challenges. Everyone here could imagine that there are challenges these days with traditional virtualization. And KubeVirt, this guy that we are going to see how it works today, the benefits of a migration if you are using the cloud, if you are using that on your machines, what will be the use cases, a demo that everyone will like a lot, example of companies. There are just two examples of what they did to get out and step out from the legacy virtualization, and finally, you will have your space to ask whatever question you want. The questions can also be driven offline, so you just grab my QR code, it's LinkedIn profile, I'm that man, but younger because the photo is 10 years ago, probably. The suit is still that one, who met me 2 days ago in a meeting that we had. I was still wearing that because I'm out of money and I don't buy a new suit. And I'm Fabrizio Sgura, a QB astronaut and chief engineer at Veritas Automata, the company where we do a lot of things like these. We are exciting, committed to do trust in automation and everything related to cloud, edge, supply chain, a lot of things that you will enjoy just looking at my profile. So in introduction, as I was telling you, these slides will be available in the repository that we have on GitHub for everyone, so you will be able to follow up and read the contents. Probably there will be an extended version there. We talk about the history here. So IBM started to do a specific set of activities in the 60s, already creating a sort of virtualization of processes. That was something that, if you are using Unix since a lot of time, you already know that there were CH root environments that could be considered like our containerization of today for the Docker initial approach. But there was something that they did in the 60s, virtualizing part of the hardware. And if you are an expert on Power Series or whatever IBM is doing in these days, they have logical partitioning on hardware that is real virtualization, but the way that is running on top of a real hardware. And then we know that in the 90s, VMware started to be available as executable on Windows, Windows Server, the VMware server on top of Windows, or on Linux, whatever they were, server, then workstation. There was something that was really available in that time, and at the beginning of 2000, it was consolidated as something available for people. So 1998, more or less, it was when they started to do this kind of abstraction. And the difference and innovation was that you could have been having your own kernel for Windows NT or for Linux running on top of a workspace that was really a virtual workspace for virtualization and running these kind of technologies. Now here we have the elapsed time. That is more or less the summary of what I said. We see 98, 99 VMware. Then I considered putting a special mention for Xen, because if you have been working with AWS in 2012, or when they started being more productive in 2015, you probably noted at that time that the kernel of the virtual machines, the EC2 instances, was having a Xen reference. That was a way of virtualizing and emulating the systems, abstracting the kernels in various kernel image disks that in AWS were called AKI, Amazon Kernel Image, and you would have been able to put your own kernel on top of that with a lot of problems, and that was how Xen worked. Then they migrated to KVM, that is the special guest of today, because KubeVirt is using KVM, so if you think to run KubeVirt on your Mac, it will not be possible. Sorry for the Apple guys, but you will have to buy a machine that is able to run Linux, because the KVM virtualization is coming from that point. You could do nested virtualization with VirtualBox on top of a Mac, but nested virtualization is very costly, so I suggest that eventually you do something on a laptop running whatever Linux distribution that you want, and following and finishing with the elapsed time in 2018, we had KubeVirt that has been evolving the world of virtualization, especially on top of bare metal. So if you plan to try on a smaller system, there are very available how-tos to run it on Minikube, to run it on smaller solution. Also on Killer Coda, you can run a sort of emulation of KubeVirt, but I suggest you do that on real hardware because it will be problematic otherwise. So what I see a potential future option that is really available in terms of market for some companies that are already abstracting the two kind of offer that we can have is that legacy virtualization. Here the icon is for OpenStack, but you can consider whatever kind of VMware, VirtualBox, or emulation and virtualization that we have can be combined with cloud-native virtualization. So running a Kubernetes cluster on the cloud, you have two realities that are always expressed with running containers on top of the two things, and reaching the combination of these two technologies will give you the ability to run mixed workloads. That is basically, you don't bother about service discovery for your virtual machines because you expose a service like you do for Kubernetes. Raise the hand if you know the services on Kubernetes and how they work. Okay, there is some presence. I will show you in the real demo how a service on top of a Kubernetes orchestration context can be exposed by a command line, just a kubectl expose with a port and something like the reference of a service. This is a big advantage for the third hexagon that we have there, that is expressing how you can control the port available for an SSH server, just exposing it on top of a running pod or a service that is inside Kubernetes. Here we have the pain points of legacy systems. How we have always experienced a limited automation because you run the virtual machine, but it's hard to have a life cycle. You will need to use several additional tools for maintaining the effective availability. Think about the same case that you have with Docker. If you run something and it's going to be powered down, if it is a BIOS, it will just power cycle the last state. But if it's a virtual machine, you will need a scheduler, so a hypervisor, or something that is giving you the ability to control the life cycle of that machine. It's not like Kubernetes that you have a pod, it's killed, it's back. It depends on errors, but it's always rescheduled. So we have this limited automation on virtual machines. It's incompatible with Kubernetes workloads. So if you have a pod that is running in pair to a virtual machine, they cannot communicate by nature. You will have to elaborate a strategy to use effectively this communication as effectively available. And you see that there I put the operational hybrid workload reference. That is basically this kind of ability that you have between VMware and Kubernetes that are not the same context, that they don't share the network, they don't share the service discovery. If you have a DNS-based way of targeting resources, it will be a configuration different for both cases. So this is really something that if you run your own data center, you will need to solve somehow. With VMware or the other KVM options, it's possible to have something that is orchestrating that for you, but generally you pay for that, and you need a DevOps team or someone that is a system administrator really able to understand all of your reality so that hybrid idea of a workload will affect consistently what is also your productivity. In challenges that we have here, I see that, again, repeating, VMware and QEMU KVM, so including QEMU KVM now, they lack the Kubernetes native integration. The management of operations, like I mentioned, it's a nightmare. You need specialized and focused people on knowing the problematic of your deployment, your use case, and if they quit the job, you will need to retrain the team to understand what you want to achieve from this kind of, let's say, configuration, management, administration. Then the resources. In a virtual machine, you say, okay, I need more or less one core CPU, one disk, I need that amount of space, but you don't have a way to constrain the resources like you could do, in example, in Kubernetes, with resource limits and specific details that are proper of a system that is scaling by default, by nature, and it's not just put there like my laptop is here, I have to buy more storage for reserving part of the disk. Instead, in Kubernetes, I can just create a persistent volume claim, and I will have the same result. And then at the end, right there, the performance. You know that if you optimize your resources in a context that could be virtual or physical environment, you can benefit from the resources that you can put on top of the system that you are running on and your applications. So your applications will run with the right amount of resources. Here you see how we can have management fragmentation. I added some points that you can read there that are briefly expressing how you can move from the inability of managing big unscalable system to gradually innovate and have a system where you can put all the changes that you need. Like in example, I put a reference to innovation challenges. When you want to adopt a new technology, that is the key focus of this, to do that on top of a virtual machine, you could need to reinstall the kernel, install new drivers, or do an upgrade of a version of something. If it's Kubernetes, generally you could have something like Canary deployments, blue-green deployments already available because you are using the right tools. But in terms of virtual machine, you could be affected by the whole bundle of things that are written down there. I hope that you see them. It's big enough, yeah. And the part related to scalability, that is the last one, but not least consistent argument is that you will be affected, also if you have a lot of resources, from the inability of innovating your strategy to come from what is a big system here with a centralized machine that is communicating to something that you have to administer. And also if it's containerized, you will have the inability to schedule the resources that are effectively available, also if you have the right size for your machinery and whatever you are having in the server farm. You see that in the animation there is how we can evolve this concept from something that is just containing everything, and this is effectively expressing how you can have your bundle that is with Kubernetes, KubeVirt on top of that, and you are the controller. So what is KubeVirt? It's an abstraction layer, it's a controller, an operator that is running on top of Kubernetes and that is understanding the QEMU principles for running virtual machines. It is understanding the KVM network and concepts related to the kernel abstraction layer for the resources, and it's also translating that for you, extending the Kubernetes API to manage these kind of resources that we will see in the demo. They are just available as custom resource definitions. So think about your virtual machine that was running on top of VMware. Now it's available in Kubernetes just using a YAML file with some lines describing this kind of concepts. The stability, I already mentioned that if something goes down in Kubernetes, generally it's rescheduled. If there are no errors, you can have this rescheduling that is available as the same resource. You don't have to restart, terminate, do these kind of activities that will require human intervention or eventually control workflow with some kind of specific tools. You have a unified management because you just have to learn Kubernetes, and we will see that the kubectl command, that is generally what you use on the command line to manage a Kubernetes cluster, is just extended with a virt subcommand that is translated also with a virtctl abstraction that is really easy to use. Unified management and cost savings. This is implicit. I will recall the cost savings because you can optimize the resources. Your deployments and availability for whatever you are doing is consistent, and you save money. Also, let's do a comparison. If you are not familiar with the current bare metal offer, and you think about AWS, let's say that you are having a stack running on AWS, and you are affected by the billing at the end of the month. In a ratio of 1/10, you could compare the same solution that you are running on top of a provider like OVH Cloud, that is giving you bare metal, poor bare metal, or Rackspace if you have a little more money, and you will save tons of money yearly with the only thing that you will have to hire someone that is able to install Linux on top of a bare metal with the IPMI console generally, and the ability to understand the concept of virtualization. So here is worldwide how we can say that KubeVirt wins and will win in the next future on top of the traditional virtual system. First of all, because it's flexible and the community is maintaining the project consistently, so there is a community of developers. It's a CNCF landscape project, very used from companies like CIVO or CIVO to maintain their deployments. There are other companies that are doing platforms like Quemby. A lot of realities that are already using KubeVirt to produce results that are available also as SaaS services. Then you have the communication. A part of the cost savings, you have support. You have a lot of options to create on top of the solution that you already run with KubeVirt, additional services, operators, scalability. Let's say that everything you can need for running monitoring, observability, it's already available because people that are using this are already creating on top of this ecosystem a lot of different options for you. And also, if you have some specific needs, you can ask to the people that are working on the repository of KubeVirt. It's already having around 800 contributors, a specific use case. They will work for that. Future-proofing, because it aligns with Kubernetes and CI/CD. So imagine that another interesting use case is that on top of your virtual machines, you want to include something like FluxCD, ArgoCD. They are all tools for managing the continuous integration and continuous delivery. That will increase a lot the productivity of your teams because developers will be having their solutions already running inside a reality that is describing the emulation of a real production environment, and it's really not that costly as having it replicated on something that is an emulation. It's a real virtualization. The real world success, we will see that we have a lot of case studies where companies that were migrating from a use case of VMware or other virtualization to a consolidation of KubeVirt, they effectively were immediately noting the total cost of ownership was half. KubeVirt is a solution because we already see that it controls all of these things for us, and the enhanced scalability and flexibility, you will just have an idea of how having this port exposure, the ability of controlling the firewall, in example, think about a firewall on top of a Unix system. You will have to run IP tables, NF tables, or interfaces that are having that potential of managing your network configuration and similar. In Kubernetes, you do just network policies. So you don't have to know all the syntax of the firewalls. Same for Windows. Imagine the dream. You can disable the firewalling and have the network policies doing the firewalling for you. It's not the best practice, but it can be. Here it's describing basically how on top of workers and Kubernetes nodes, you can have this KubeVirt, the V that you have there, it's that logo, and mixed workload with VMware or converted machines, virtual machines, applications that are containing both virtual machines and containers, or just containers. And this translates in a distribution of your needs on top of the nodes that are running Kubernetes and KubeVirt. So distributing means scaling, means benefit from this kind of configurations that you implement on top of that. You see that, again, real-world impact, the legacy applications costs, scalability problem, and also productivity are completely gone. And we have an improved capacity of knowing what we are deploying. So it's like monitoring observability. If you are familiar with suites like, I don't know, an enterprise, New Relic, Dynatrace, whatever, you're sending a lot of data and you're not knowing what is your effective data and the need for that information. Unless you start to classify. With KubeVirt, you can classify the workloads and have a big benefit from all of these things. Now we have finally the demo space. I will just describe what we will see in the demo because it will be quite extended. And I want to satisfy your curiosity also for the next questions that you will have. You see that in the right side of this slide, we have how it will be the system composed. I also have a video in the demo that I created because there are long processes like the disk conversion, the Terraform deployment, The demo is based on a Terraform stack that you will find on the GitLab repository that is also available at the QR code, but if you ask me, I will share that. The demo is running on an RK2 Kubernetes cluster. It's a special SUSE distribution based on a Rancher console. We will see the Rancher console. I've been using Longhorn as a storage class, so you will see something that if you are familiar with storage, it's an abstraction that you will say, okay, it's a RAID 5 because there are 3 replicas. It's something for the people that likes the screwdriver in a data center and changing disks the old style and the old way. Then we will see how we deploy the pods and components after seeing the Kubernetes cluster and how it's done. Again, Rancher Longhorn. KubeVirt installation, it's quite easy, simple. You just have to run the command calling the Kubernetes API with the manifest endpoint, but in the Terraform stack, it will be automated. So if you run that stack locally, you will have KubeVirt already installed. Container data importer is a concept that I will just spend 2 minutes now. In Kubernetes, you can have a container network interface called as a CNI or a runtime interface that is generally CRI. You can have CSI storage interface. And for KubeVirt, they implemented this data importer component that is nothing more than you have a disk of a virtual machine, you convert it, and you import it in Kubernetes as a persistent volume. So not being familiar with Kubernetes storage, just in 2 seconds, it is having persistent volume claim, that is the connection with your pods and your components, and a physical space where you have your disk image, persistent volume. The persistent volume is produced thanks to the container data importer that is generally using a quick code 2 as the format of the source disk because it's KVM QEMU based, and it is producing the disk of the virtual machine. The rest of the things is done by the KubeVirt handler that is running as a demo set. So on each node, there is a copy of the pod that is giving us the ability to provide this specific disk to virtual machine translations. And I will show you how you do the conversion, because generally if you find the how-tos on the internet and you follow them, they will implicitly say that you already know how to do a disk conversion. It's not simple, but it's not complicated. It's just a 1 single line command. Then to expose these services, since I'm working on bare metal and everything is running on my laptop, I will just show you briefly the inventory of my current resources. You see that I have an i9 processor with 24 cores and 128 gigabytes of RAM. That does mean that you have to increase the RAM capacity if you want to run the full stack, but it's not really needed because you can run the same thing with 64 gigabytes of RAM. If you buy hardware or you go for bare metal, you will just take care that you have enough resources to run a multi-cluster Kubernetes Rancher distribution or other distributions. And finally, the manifest and operator for VMS, I will show you how you can easily, very easy, describe how a virtual machine is translated in a few lines. So let's start from the next, it should be the video. I will, if the video is not working, don't worry, because it was supposed to be working for the case where we lose the internet, but I don't think it will be needed. So at the beginning, I'm just creating the Terraform stack. So it will be basically a Terraform apply. Okay, here you see that just posing, I have on the right the libvirt virtual machine manager that is a translation of a console. There is nothing running there, nothing is being produced. Terraform init is here for us because it's what we are going to apply after the plan. to have this cluster up and running inside the existing virtual machine manager. Let's see if it moves. Otherwise, I will move it forcefully because it's just a helper. So here I'm explaining the plan. There are a lot of resources. I will show you just briefly the Visual Studio Code with the Terraform structure for this specific repo that I have created. And now scrolling, it's the plan. So everything that will be applied, I just did this in the video to show you that the complexity is full of resources. We are configuring storage. The token for accessing Kubernetes is really completed. There is also a version with K3s if you want to play with that in the repo, an alternative one. I created the storage. Now you see that I will apply the plan. And here on the right, you will see appearing the 5 nodes. So this will be exactly the same situation on your machine. The 5 nodes are starting up. I'm using Cloud Init for configuring everything locally. So you just run a cloud image of Ubuntu for this case, and it will create the whole stack. Here I show you how the virtual machine console is available inside Virt Machine Manager of QEMU. It will be the same like running the SPICE interface connecting to a console interface of the virtual machine. And it's familiar to everyone probably how you can access the console. And here is the description of the resources that I'm using. So it's a normal machine emulating a Q35 that is a QEMU specific base machine. There is no UEFI, but you can also emulate the UEFI machines. You just need to be sure that your host is transparent, because otherwise nested virtualization will not be possible. I am using 16 gigabytes of memory and 4 core of CPU for each of the virtual machines, and Virt.io with the basic disk mapping for drivers and similar for mapping the disks of the machine. Translating this to a real case here, what you are seeing is exactly what I have now running for the demo. So nothing different from what we saw here. And for the part related to the source that I'm going to show, they are not in the video, I started with typical VMware workstation downloaded from Broadcom. It's for free now. And creating a Windows server. Really? A Windows server. You will see a Windows server running inside Kubernetes. No Windows containers. It will be available. We will just show the Internet Information Service and eventually an RDP connection, but I don't want to do too much Windows. So this was created with VMware. It had a specific disk out of there. I haven't updated VMware because I don't want to use it anymore. It was just for this demo. And at the same time, in my virtual machine manager, you see here, I cannot zoom, but this is the converted disk of Windows. This is the Ubuntu that we will see it's running also as a virtual machine inside the Kubernetes cluster, the RKE2 one. And going back here in the video, this is the part related to the initial access that I did via SSH to the nodes. And on these nodes, there is a meta load balancer that will expose the services for us. So we will see that we are able to effectively see everything. It's really essential, but if you grab the repo, you will be able to run exactly the same things. So it will be very inspireful for many people. I think that there are not that much practical approaches for doing all of these stuffs all together without the problem of finding the documentation. I will just zoom a little on what are these commands. I cannot zoom because it's gedit. I should change editor, but I will describe them. This command that is available in a gist parallel to the repo is how you upload the disk that you created. And if we look at the terminal that I'm going to show you now, you will see how we have the size of the disks. So let's start from the disk of Ubuntu. Here I can zoom. Let me see if I can find the, okay. Now, what I will do here is just referring to the size of the disk. This is where I created a Ubuntu disk image. It's a quick code too. And you see that here I will have a 16 gigabytes of disk created. So I decided to use all the space. You can also let it expand as time goes by. These are the disks of the cluster. So RKE2 disks are here. You can see that the size is super compact because they are just the installer for the operating system. And this quick code 2 is the disk image for Ubuntu that we will see it's running as a virtual machine. I should also be able to show you the Windows one, that is this specific disk. Again, I will expand for you a little. In this case, it's a 13 gigabyte quick code 2 Windows 2000 server, but really it's 43 gigabyte because in this case, I didn't want to use additional space. I don't have specific plan for Windows here, and the disk is compact, and I used it to convert this disk to quick code 2 with the QEMU image convert. So I will not show you the commands, but it's a one-line command. You specify the source, that was VMDK, for my case. I think that we could just see inside the Windows, let me see if I can find it. Windows Server, yeah, this one. Here is the source. So the VMDK suite with the VMX describing. Again, I can expand here. You will see that if you are familiar with this kind of VMware virtualization, you will see the typical structure of VMDK. And using the QEMU image convert, you do the VMDK to the quick code 2, and then you just have the disk ready to be imported on your KubeVirt deployment using the command that I was showing here. And here, sorry again, because I cannot expand, but it's available in the gist. I will read it for you. Virtual CTL image upload. You specify the name of the PVC inside Kubernetes, the namespace at the end, various things like disk size. It has to be explicitly declared, the path of the disk, lot of arguments that will be generally documented in the virtual CTL image upload subcommand. Thanks to the exposure that I did of the service endpoint via meta load balancer of the uploader, the CDI, this will target this endpoint that is specified here and upload the disk. It generally takes some time. I think that in the video here, I have a specific reference to this operation, and we have enough time to take a look at the elapsed things that are here in the video, so why not looking at them? Here, I'm just describing the meta load balancer address pool, so I decided to expose a pool of IPs that are really the same network of my machine for exposing the services like the upload proxy, that is what we are talking about right now, because it's the endpoint where you will upload the disk. I put an evidence on that here. And having that exposed, I can import the disk, and the result will be basically the fact that we will be able to encut to the port 443 of Kubernetes API, in this case. Everything will be describing that thanks to exposing these services for the upload load balancer endpoint, we have the port 443 working, port 443, And here, this is exactly the command that I was translating for you, the part related to the upload. We will see now that in the elapsed time, a disk of 15 gigabytes will be imported in 1 minute. So if you are impatient, you just have to go grab a coffee if you drink it, and you will have the disk imported. We will obviously skip the elapsed time. I didn't this for Windows because it was more time, it was 43 gigabytes. At the end, you will find the fantastic message that it worked. If it's the first time, you will probably light up a candle or something like that because it's really a great satisfaction. Now, apart of that, you will eventually, after having the disk inside, starting to look at the PVC, how it's done, things that we will see visually using the Longhorn interface. And here, elapsing the time and scrolling more on the video, now it's time to define a virtual machine. You see that in the whole screen, this is the manifest describing your Ubuntu machine. For Windows, you just have to do some other things, obviously. One is CPU exposure. You will need to extend the concept of a core that is really host-based, so nested in nested virtualization. Here we define the memory resource only and the Virt.io disk. For Windows, you have to use SATA and the driver for the Ethernet 1000 adapter because otherwise you will get crazy installing the Virt.io driver in Windows. But basically describing the virtual machine with the describe command, this is the result that you will see once you have imported the persistent volume claim and the virtual machine is up and running. So the video here should come to an end because I wanted just to consolidate all the steps that were really time-consuming for us. Now we can go. Maybe there is something more. Let's see if the video is completed. Yeah, this is an access. So why not showing you something that you will see later, a virtctl command that is how to start your virtual machine here, virtualctl start. You have a VMI that we will see it's available. In this case, it's just for Ubuntu. It is running. It's how you see virtual machines in Kubernetes. Just one command and the status of how it is. And then, finally, now we do the VNC subcommand that will open a SPICE terminal. Now, just one time, this is the SPICE terminal. This is the user that I used at the beginning, but the password is Ubuntu if you want to hack it, and Ubuntu inside virtual machine. On top of this Ubuntu, I also installed, and I will show you now, K3S. So Kubernetes inside Kubernetes, virtual machines inside virtual machines. Space for your fantasy. Whatever you want to do, it's really your limit. KubeVirt has no limits for this case. In the video, I haven't included, I think, Windows, because I want to show you Windows directly from my command line. Here I'm installing curl just to show you that if I query from this virtual machine the kubernetes.default.svc.cluster.local, which is the API of Kubernetes, I don't have to bother about service discovery. The virtual machine will understand the endpoints of the Kubernetes cluster directly from inside, using the same DNS. It's an authorized because I'm not providing the token. But if I install the K3S YAML or the kubeconfig file for accessing the cluster, then it will be available also from inside the cluster. Think about your developers will run a virtual machine for developing inside the Kubernetes cluster, and you will give them exactly that environment that is their workstation needs, and they have the ability also to communicate with the big cluster that is running their specific machine. So I think that the video is enough. I don't want to extend more the video. Yeah, you can go for a question right now if you want.
Maps that are mounted to this resource back into the VM so you can do things like the service account
Exactly. I have no case like that because I wanted to keep it really essential. But think about that whatever you do for a pod is your virtual machine. So role-based access control. In example, you do a service account with a specific kubeconfig to give that kubeconfig to the developer that is using just that virtual machine that you are running there. Inside the machine, it depends if you give to the machine the access, but it can be done. So on top of the manifest, it is really like a pod. I will show you the pod now. So first, let's go one by one with the things that I have here. First, the cluster. This is where we are running Kubernetes, and this is the RK2 cluster with 3 masters and 2 agents. I could have been doing just one node, but it's for everyone to play. They will be having a real case scenario. So you have, and it's nested virtualization. So this is KubeVirt. If you have money and you buy 5 OVH cloud nodes, you can have 5 nodes with real virtualization for the KubeVirt machines. It will have 10 times better the performance. Here I have the pods that are running. Second chapter for our presentation will be that there is also the monitoring. So I installed in another part of the repo Grafana with Prometheus. You install a node exporter on each node of the cluster, and KubeVirt is giving you dashboards. I also installed Loki, that is basically to see the log files inside Grafana. And one by one, look at Longhorn. So the part related to the storage, this is partial deployment of Longhorn, but we will see it in the UI. This is just for managing the consistent storage. You can also do that as a local storage single disk, but it's better to have it in RAID. So you will be sure that Longhorn is managing the consistency of your storage for you. Look at how many resources are here in this Longhorn system namespace. So there is time for additional presentations there. And here, the Virt operator. So first, double copy of the operator. You know that the operator has a reconciler, listening to Kubernetes events, reacting to that, and doing specific activities depending on the rest of custom resource definition that you define. The handler is a daemon set that is acting, controlling each node for the resources. Then there is a controller that is basically the translation for the API to be creating virtual machines, reserving spaces, and similar. Here, when you install RK2, there are some jobs that are completed to install Ingress Nginx controller, Core DNS, and other things. And here there is the typical Kubernetes rest of things, the kubeproxy and the part of the Kubernetes installation for RK2, the etcd cluster for 3 masters, Cloud Controller because I did it with a cloud image, Cert Manager, why not including it, and the CDI, that is that container data importer we were talking, and the Rancher UI with Fleet installed by default, Common Storage Interface, and Calico as the container network interface manager. As you can see, it's a lot of things. But they are bundled, and you will not bother about installing all of them if you have to follow the steps that I produced in the repository. One important thing, each virtual machine can be namespaced, so I can isolate one from the other. If I want to become a cloud provider or a provider for my developers, one single namespace could be for one or a group. In example, QA team will just see QA team. The machines running there will be isolated. I can create network policies, filtering by labels, annotations, a lot of things that we do in Kubernetes. And here the lin and win are 2 different namespaces. This is how you see generally the two machines running. The reason for why I'm running the commands live now is because I want to be sure that everything is up and running. The ready true. There is another thing that we can do apart of getting the VM. It's the VM instance. So what is the IP of that machine and so on? Think about one important thing about the IP and network configuration. You don't have static IPs. Incredible. How can I manage service discovery without static IPs? Core DNS, Kubernetes DNS. Solved the problem of nights and days not sleeping and having a lot of coffee because of service discovery. And if you know Kubernetes, you know that this will be Ubuntu 24-kvm.vmlin.kvm.svc.clusterlocal or .whatever, and that will respond exactly to this exposed VMI, VMware instance, virtual machine instance IP. This is the representation of how you can expose a service. You see that I was mentioning earlier that we would have been exposing for Ubuntu something. Again, I will expand a little more. I can SSH Ubuntu. I can use the 6443, that is the Kubernetes API of Ubuntu that I use to install another K3S inside Ubuntu. And for Windows, we will see just IIS, and the RDP, I will not connect with the RDP because I will use Spice. It's easier. These are, again, the disks that we saw earlier. This is the converted disk, and finally, we are reaching the window where we will connect to our virtual machines. A little bit of more size. VirCTL VNC to the machine of Ubuntu, enter. Here is our Ubuntu. This is a virtual machine running inside our cluster. I will just enter the Ubuntu password because it's safe. It should take not that much time. Okay, it's the first access. It's a virgin machine. This is Ubuntu, so you know about that. Let's open a terminal just to show you that what I was saying earlier is we become root because K3S is installed with the root credentials, and we do a kubectl get nodes, and this is K3S cluster inside Kubernetes. This is our friend Ubuntu. Now let's go for our enemy or other friends, Windows. It depends. Again, expanding this. VirtualCTL, Ubuntu, not Ubuntu, Windows. Faster than Ubuntu. Sorry for not paying the licensing. I just downloaded the part related to Windows. I exposed IIS. I will show you now IIS. This is running inside Kubernetes. No tricks, nothing. I could show you, but we will run out of time, that NSLOOKUP will give us the same Kubernetes default SVC cluster local and whatever other. It can intercept the other virtual machine too. So basically here we have the two spice option. I will remove both of them and I will give you the part related to the Rancher console. So if you use Rancher, you can use your workloads here, like if you are able to use K9S or Lens, something like that, use Rancher, it's better, it's already running inside. You have everything. You have a fantastic marketplace, so if you want to install your favorite NAT server instead of Kafka or Istio, you just click here and it will work. And then, apart of all the other things, it's not Rancher our target today. Longhorn, this is the storage interface where we can do snapshots. We have RAID 5, so if we go here to nodes, we see our nodes cluster. And this is like Portworx, but for free, included in Rancher. These first two are the 46 Windows gigabytes the 46 gigabyte Windows disk in RAID 5 with 3 replicas, and the other one is the Ubuntu one. I think that here we have IIS running on top of a exposed service. This is from Windows. This is me. Don't look at the face when I have my arms this way. And this is for another time. Go ahead with questions. I see one. And I will conclude the slides, because otherwise we will lose a lot of contact with the rest of things here in the presentation. Go ahead with the microphone. Let me see if I can talk about the use case.
So if I understand this right, this is running on Kubernetes, and then how many pods are supporting the virtual machines? And then can you kill the pods and it still serves?
So
stability is what I'm asking for.
I will give you a very, very brief answer just doing the pod enumeration. You remember that here I did a get pods-a. These are the 2 pods running the virtual machine. 1 pod per virtual machine. You can scale them up, but it does absolutely not make sense. Remember that they are connected to the persistent volume claim, so they share 1 disk. There is a way, and this is curiosity that you could ask for, to use a read-write many because of Longhorn, so you can have several pods accessing the same disk, and concurrency is managed by the NFS under the hood controller that Longhorn has inside. You can also use Ceph if you want to use Rook and shared access. But in that case, you will have to ensure that you have a read-only part of the operating system, like an AWS workspace, and the developers are using their own specific persistent volume claim. So that's up to you, really. It's full of ideas that you can implement on top of that. Go.
In the virtual machine manifest, how granular can you get when you create the virtual machine? Like specific?
Can you raise the voice? Because
in terms of defining like the instruction set for a CPU or PCIe device pass-through or per virtualized device that you want, how granular can you get when you define your virtual machine in the manifest?
So imagine what I showed you here about QEMU. Let's see together again an example of a virtual machine just to give you an idea. I will use the Ubuntu one. So I'm opening the part related to the resources. Here is the complete XML, if you want to do that, of all the resources, including things that we are not using, like a trusted platform module, emulation from the motherboard, whatever. All of these things can be translated to the CRD. There is a responding entry for everything. But I didn't implement the whole bundle because by default, all of these values are chosen by QEMU at the beginning. But if you want to be specific, you can really implement fine-grained virtual machine configuration. And I will just show you the part related to Windows. So this one, sorry because I cannot zoom. Maybe I can. Let me try. No. This is the Windows custom resource definition from here to here. And to show you the difference, I have a host pass-through here that I used. Here I have a disk bus SATA, a network interface that I had to define to use the bridge, nothing, Ethernet 1000. So all the things that you define inside QEMU are customizable. Go ahead.
I'm afraid we're actually out of time. We need to allow the next speaker to set up. But you can talk to Fabrizio in the hallway and get your other questions answered. Thank you so much for that presentation. That was excellent.
I've been happy to share the practical part because eventually the use cases that are missing, you will find them in the presentation available on the Git repo. Add me on LinkedIn. There is the QR code, but you search for my name. It's available in the scheduling from scale, and you will have all the answers that you need. Please use it, because it's the future. Maybe one day you will remember me as the fortune teller, but this is the future. Congratulations, everyone, for having the patience. Thank you.